Well, hello and welcome back. We're off to one of our tougher topics of exponents. So stay with me. You probably have to do quite a bit of pausing and rewinding if I talk too fast. And this is our one day to get these exponents down, all of our properties. Good luck. Alright, so let's go ahead and list these definitions in our notebook. Number 1, when dividing blank exponents. What word are you thinking there? When dividing, subtract exponents. Number 2, when multiplying blank the exponents. When multiplying, hopefully you're thinking add the exponents. 3, negative exponent rule. X to the negative a equals 1 over x to the a. And there's a little note there. Remember that x cannot equal 0. You cannot divide by 0. Okay, so a negative exponent basically is just going to flip us either to the top or to the bottom. If I'm already on the bottom, 1 over x to the negative a, all that's going to do is flip me up to the top and I would get x to the a. Okay, so that negative exponent is just moving you. You can think of it like that. Number 4, fractional exponents. X to the m over n is equal to the nth root of x to the m. Here's the way I always think about it. Picture any flower or tree or whatever it may be. Where do you find the roots of a plant? Hopefully you're saying the roots are always in the bottom. And that's how I remember this. The root is always in the bottom. Okay, so this is the name of the root. That number goes on the bottom of my fractional exponent. So if I said the fourth root of x, I would say that's equivalent to x to the, I know the 4 goes on the bottom, that's the root, 1/4. Okay, because of course this exponent is a 1. The other way to think about it is think about the exponent here is always going to be on top. Next rule, my 0 exponent rule. Anybody raised to the 0 is a 1. It doesn't matter if it's 3x cubed to the 0 or m to the 0. Every answer there should be 1. Alright, so now that we've identified the rules, let's go ahead and practice some regions type questions. Alright, evaluate 3f to the negative 2, g to the negative 3rd, 2 to the over 2 to the negative 1, f to the 4th, g to the negative 4th. So I'll just tell you what goes through my head. Okay, basically everybody has a single exponent, and I just say all the operation I see is division. And when I divide, I say in my head, okay, I'm just going to subtract exponents. Alright, so I'm going to well, let's just start with the g's here. If I subtract the exponents, okay, and literally write the number on top down, negative 3, we said subtract. What is the bottom exponent? Be careful, it's actually a negative 4. So I end up with negative 3 plus 4, which is 1. So I know I'm going to get g to the 1st. Let's do the same things with f. The top exponent is negative 2 minus, looks like a positive 4. That's going to get me a negative 6. I'm going to get f to the negative 6. Now, notice the 3 and the 2 here. Are they alike? Alright, you can't subtract exponents if they're not alike. Notice I didn't do g and f. I did g and g, f and f. Are 3 and 2 the exact same term? No. So you can't subtract their exponents. So for that, I'm going to say I have 3 over 2 to the negative 1. And because this exponent's a negative, I can now move it to the top. So I have 3 times 2 to the 1st. And I have f to the negative 6, g to the 1st. And I'm going to clean it up one last time. I'm going to say, all right, I can now multiply these two. 2 to the 1st is 2 times 3 is 6. Because this has a negative exponent, I'm going to move it back to the bottom. And g has a positive exponent, so it's going to stay on top. And there you have it. So maybe you have to pause and rewind and do what you need to do, but we need to get these problems down pat. Let's try another one. Alright, I've got x to the negative 8 y cubed divided by 5 x squared y to the negative 6. Why don't you pause it, try it on your own, and then I'll walk you through it. See what you get. Alright, so I'll talk you through what's going in my head again. I'm going to start with the x's, and because I'm dividing, I'm going to subtract. And I write it off to the side. It's negative 8 minus 2. So I get x to the negative 10. I'm going to do the same thing with my y's. So I've got 3 minus, my bottom exponent is a negative 6. So that gets me y to the 9th. Those turn into a plus. All right, now, where is this stinking 5 sitting? All right, it's clearly on the bottom, so make sure you keep it on the bottom. Notice I didn't put the other 2 on the bottom, but I have to keep that 5 on the bottom. Now I can say, can I rewrite this any other way? Well, this guy has a negative exponent, so it can also move to the bottom. So I end up with y to the 9th over 5x to the 10th. Hopefully you got the same thing. All right, we're going to make this one even a little uglier. So I've got 4x to the negative 2y cubed divided by the quantity 3x squared y to the negative 4th to the negative 2nd. Now you'll notice this one's different because this one has this whole set of parentheses raised to the negative 2. So watch what I'm going to do first. I can take all of this junk here and I'm simply just going to move it up to the top because of this negative exponent. So I'm going to say I have 4x to the negative 2 y cubed. And notice I'm taking the whole set of parentheses. I'm not changing anything in there. Just rewrite exactly what you have. But this time raised to the positive 2. Okay? So again, I just move that whole set up to the top. Now I'm going to go through. I'm going to rewrite this term. There's nothing fancy here. But the second term I have to be careful with. You have to do what to everybody inside here? You have to raise it to the second power. So what is this 3 going to turn into? Well, remember, it's 3 squared, which is 9. Power to a power says you're going to do what operation? Hopefully you said multiply. And then I should get y to the negative 8. All right, so hopefully you're still with me. I rose everybody in here to the power. And again, power to a power is multiply. Now, what operation are you doing here? Do you see any plus signs? Heck no, you're still multiplying. So what was our rule for multiplying? Well, it was to add exponents. So first of all, 4 times 9 makes 36. All right, my rule is add exponents. So I have negative 2 on the x plus a 4 gets me a negative 2. And on my y's, I have 3 plus a negative 8 gets me a negative 5. And lastly, I'll say, can I rewrite this? And of course, anybody with a negative exponent, I will just shift to the bottom. X squared y to the 5th. And there you go. All right, I'm going to switch gears on you and get back into fractional exponents. Now, remember what I said, and just think of a tree or a flower, whatever the case may be. Where do you find the roots of a flower? On the top or the bottom? And again, the roots are in the bottom, the ground. So that means this number on the bottom is the root. So I can say this is equivalent to the square root of 16, and it's that quantity cubed. Now notice, that's the same thing as the square root of 16 cubed. It doesn't matter which way you write it, they are equivalent to each other. All right, so as I simplify this without a calculator, clearly you could type that in the calculator, that's a very simple answer. Let's talk about doing it in our head. For those of us moving on to, pre-calculus or maybe even taking the bridge and doing calculus, we got to be able to do these in our head. So you're just taking the square root of 16, hopefully you can do that in your head, the square root of 16 is 4, and now you're raising that to the exponent of 3. So square root of 16 is 4, cube it. Hopefully you've got 64. Let's try another one. 8 to the 2/3. Rewrite it as a radical. It's really the what root. Remember, roots are on the bottom, so cubed root of 8. And again, you can say it's that junk squared or the cubed root of 8 squared. Cubed root of 8 is 2, and 2 squared is 4. All right, we'll keep chugging. Now, I made this one even uglier because I threw a negative exponent at you. So there's 2 ways to think about it. The first thing you could do is just pretend it's not there. I could just say 4 to the 1/2 and ignore it for now. Okay, so 4 to the 1/2 means take the square root of 4, which is 2, and raise it to the first. So I get an answer of 2. But now you do have to remember you had a negative exponent, so let me put my negative 1 exponent in there. Now my answer turns into 1 over 2. Okay, so you can ignore the negative exponent and take it at the end, Or let me go through the same problem taking care of it first. I could say because this exponent's negative, this is really 1 over 4 to the 1/2, and do the same thing. 1 over square root of 4 is 2 to the first, which is 1/2. So again, whatever you prefer is fine with us. Just pick something and get it down. Moving on. All right, let's simplify this radical, and then we'll try to write it with fractional exponents. So I'm going to say this is really the square root of 16, the square root of x squared, and x, and the square root of y squared. And I think you would agree with that. Most of us are pretty good at that. I know 16 turns into the number 4. The square root of x and x squared make x. The y and y squared make y. And I'm left with radical x. Now, if that's not a choice on our multiple choice, here's what they could also write. 4xy, and then x raised to the what power? Well, what type of root is this called? Remember, it's called a square root. So I could say that root goes on the bottom to the 1/2. Now, watch how tricky they're going to get. I could say that's 4y and x times x to the 1/2. When I multiply these two x's, what am I going to do with the exponents? Add them. So this guy has an exponent of 1, so I have 1 plus 1/2, and again, 1 is really 2 over 2. So I could say I have 4yx to the 3/2. Again, if at any point I'm talking too fast, pause it, go back and make sure you understand that. All right, next one. 8 over 27 to the negative 2/3. Why don't you pause it, see what you get. All right, I'm going to quickly show you the two ways. You could pretend the negative's not there and say it's 8 over 27 to the 2/3, so I'm just ignoring it. And I'm taking the cubed root of 8 over 27, and then I'm squaring it. So the cubed root of 8, remember, just do it to the top and bottom. The cubed root of 8 is 2. Cubed root of 27 is 3. And then I have to square it. So that's 4/9. Okay? Now you have to remember you have a negative exponent, which turns this now into 9/4. Okay, that negative exponent is flipping my fraction. Let's try it the other way. Maybe you want to leave that negative exponent. So I would say that's 1 over 8 over 27 to the 3/2. All right, I moved it in the beginning. So I have 1 over, oops, I should have said 2/3. 1 over the cubed root of 8 over 27 squared, which again is 1 over 2/3 squared, which is 1 over 4/9, and if I clean that up, I get my 9/4. So either way, we should get the same thing. They definitely take time, and by no means, I mean, you could certainly throw that in your calculator, but for anybody moving on, we got to know how to do this by hand. All right, a couple more to practice here. All I want to do is rewrite this. Okay, so again, this negative is going to turn this junk into a fraction. Now notice, does the 2 have a negative exponent? No. So that 2 is going to stay on top, and this x plus 1 to the 3/4 is going to move to the bottom. And lastly, I'm going to rewrite that one more time by saying it's the what root, roots grow on the bottom, 4th root of x plus 1 cubed. And that's all I'm looking for, just rewriting. Okay, let's try another one. Let's rewrite this one. Okay, negative exponent moves us to the bottom, so 1 over x to the 1/4. So that's 1 over, what type of root? Roots grow on the bottom, 4th root of x to the 1st. Keep moving on. I want to compare these two. These two are very different. Notice, it's all about who the exponent is sitting on. This negative 1/4 is strictly sitting on the x, where in this case, the 1/4 is around both of them because of the parentheses. So watch how different their answers are. The 3 has a positive 1 as an exponent, so that stays on top. This is going to move to the bottom as x to the 1/4. So I get 3 over the 4th root of x. Where in this side, notice they're both going to go to the bottom because they're in parentheses. 3x to the 1/4. So I'm going to get 1 over the 4th root, of 3x to the first. Okay, so this term, the 3 stayed, this term it went. Watch those parentheses. All right, your turn. Pause it, rewrite both of these, and see if we get the same thing. In this case, okay, the 3x is going to the bottom and being squared with a 1 on top, versus this case, the 3 is going to stay here, and just the x squared goes to the bottom. So I can't stress enough, it's who the exponent is sitting on. All right, another common mistake some of us are making. Let's go ahead and compare these two. So get these both in your notebook. I have x to the negative 2 y cubed over x y squared versus x to the negative 2 plus y cubed over x plus y squared. So clearly the main difference between the two is these were multiplying and these were adding. Watch how I solve them. When I'm multiplying, I'm just going to take my exponents and subtract. So I'm going to say I have negative 2 minus 1 is negative 3, x to the negative third. Same with my y's here. I've got 3 minus 2, so I get y to the first, and I would say my final answer is y over x cubed. Now this is completely different from this problem. I can't just go around subtracting exponents because I have this plus sign here. You've got to rewrite each of these. So this top one turns into 1 over x squared plus y cubed, really over 1, all over x over 1 plus y squared over 1. Do you see how drastically different these are? This was not a complex fraction at all, and this turned into a complex fraction. And the whole difference was whether you're adding or multiplying. Next rule, just want to stress this power to a power rule. This is a big issue we seem to have this year. It's just multiplying exponents. Again, you know to multiply, most of you, but you multiply wrong. Basically, I'm saying I have 4 times 2/3. Okay? 4 is not 4 over 4. How do you write 4 as a fraction? 4 over 1. So this exponent is actually x to the 8 over 3. Okay, so let's be very careful. If you don't have a fraction, turn it into one, and it will make your math a lot easier. All right, I'm switching gears, and I want to talk about some polynomials. When this group is subtracted from this group. So let's get one thing straightened out. When you see the word from, we got to say from comes first. Okay, get those F's together. From comes first. So I'm just going to rewrite this. The one that says from is this bear. So I'm going to say this is 5/2 x squared minus 3/4 plus 1 minus 3/2 x squared minus 1/4 x minus 4. From comes first. The second huge mistake we got to be clear of is subtraction. All right, we're going to change. We're going to rewrite it every time. It takes a few moments, but that's okay. Oops, I think I missed my x there. Plus 1. Change subtraction to addition, but that means you have to change every sign. Minus 3/2 x squared plus 1/4 x plus 4. Now, I want to be very clear. You don't need to be a hero and do all of this in your head at this point. All right, our goal is to get it right on the exam. So if you can't add fractions in your head, that's okay. Grab your calculator and type them in. 5/2 plus negative 3/2. If you can't do it in your head, do it on your calculator. You should get 2 over 2, which is 1 x squared. Negative 3/4 plus 1/4. Again, if you can't do it in your head, grab your calculator. I get negative 2/4 or negative 1/2 x. Positive 1, positive 4 gets me a plus 5. And you're done. Once you've added your like terms, you're good to go. This time the question says, what is the product? Product should give it away. When you see product, you need to multiply. So if I want x to the 4th minus 1/3 times x to the 4th plus 1/3, all right, that word FOIL's got to jump right in my head. And again, don't be a hero. If you can't do it by now, let's not waste our time. Let's grab our calculator and go. First, x times x is x squared. 4 times 4 is 16. Outer terms, plus 1 over x and 12 minus x over 12 plus, minus 1/9. Okay, at this point, if you can't do it, grab a calculator. Like terms would be these two. I have 1/12 minus 1/12. I think those are a wash, and I get x squared over 16 minus 1/9. Now, some of you like to play with that even further. You're done. All right, once you've foiled and put your like terms together, we're finished. Well, that does it for us today. So take good notes. Hopefully you did a lot of pausing and rewinding, and this is definitely something we're gonna have to practice. We'll see you tomorrow.